Today's focus is going to be on significant figures. Significant figures, also known as sig figs, and that's pretty much what I'll refer to them as, or significant digits, are a technique that scientists and mathematicians use in order to round. All it is a rounding technique. And why are they important for us? Well, as scientists, we take measurements over and over and over again, and we're only as good as our measurements are. And we don't want to be, don't want to say that we were more accurate than we were supposed to be, and we also don't want to say that we were less accurate than we were supposed to be. So if I were to look at this second arrow right here, okay, what should I measure it to? Well, should I measure it to 6, 5.7, or 5.724931? Which one is most likely the best answer? Well, it should be 5.7. Why? Because we can be more accurate than just saying 6, but we definitely cannot be as accurate as 5.724931, right? Okay, so therefore 5.7 is the best. A good way to do it, just to let you know when you are taking measurements, whatever your digit is, so this is the ones digit, so we're between 5 and 6, you always go to one decimal further. So we could do something in the tenths area, okay? And that's why we would do 5.7, right? So we could, because we can estimate this last digit. That's what it's known as, is the estimated digit. So you always find whatever number you're in between, so let's say this, okay? And let's say this said 1.1 and 1.2 and 1.3 and 1.4, okay? Now let's say I'm at, well, I'm midway between both of them, so I'd be 1.1, and I can go one further because this is in the tens place, so I can go to the hundredths, and I would say 1.15 for this black arrow right there. Okay, but we need to convey that. We need to convey how good was our instrument that we used, and so that's where we get sig figs. Okay, so first you're going to have to know how to count sig figs. And so I use this PA system. So where it's Pacific or Atlantic. I always think of Atlanta, Georgia, and that's on the Atlantic. Okay, Pacific, you think, oh, pacify, chill. That's what I think of California, so that's the Pacific. Okay, so the first thing you want to do is you want to see if your number, which is down at the bottom, this right here, is the decimal present or not. By present, do I literally see it or not? In this case, I do not. So I'm going to go from the Atlantic or the absent side. Why? Because the decimal is absent. I'm going to start counting at the first non-zero number. So I'm going to start from the left, start from the right, go to the left. I'm going to start counting at the first non-zero number. So it would be 1, 2, 3, 4, 5. And you keep counting till you run out of numbers. So this guy would have 5 significant figures. Okay, it has 6 digits, but only 5 of them were accurately measured. So what it's saying is the instrumentation used, I accurately measured this guy right there. That is the estimated one. I accurately measured up to there. All right, let's try the next one. Okay, so 300.0. So this is what's really interesting. 300.0 is not the same as 300 with sig figs and with estimations. When you have 300, you are saying that this guy is where you accurately measured to. When you have this one, you're saying that this guy is the one that you accurately measured up to. So it's just a little bit different, right? It's a different philosophy of how accurate you can measure. All right, so see if a decimal is present or not. It is present right there. So go count from that direction. So we're going to start from the Pacific or the present side, which is the left side, and we're going to work our way into the United States, right? Start counting at the first non-zero and keep counting till you run out of numbers. So we've got 1, 2, 3, 4. So this would have 4 sig figs. All right, let's try the next one. So notice we would say numerically it looks like the same number, but it's not according to rounding and significant figures. This 300 was measured with a worse instrument than the 300 with a 0.0. Okay, so is it decimal present? Nope. So it's on the absent side, so we're going to work our way in here. Start counting at the first non-zero, keep counting until you run out of numbers, so this would have 1 sig fig. 1.5 times 10 to the 5th. So this is scientific notation. With scientific notation, you ignore the times 10 to the 5th. Okay, and so what you're going to do is see if it's present or not. So we've got 1.5. 1.5, I do see a decimal, so I'm going to go this way. So I'm going to start counting at my first non-zero, which is 1, 2. So this would have 2 sig figs. This one is present, so we're going to start from the left side. Start counting at the first non-zero, which is 6. Keep counting till you run out of numbers. So 1, 2, 3, 4, 5. So this would have 5 sig figs. Remember, once you start counting, you keep counting till you run out of numbers. That's the key for all of these. Okay, so first you have to know how to count sig figs. Now you need to know how to round sig figs. Okay, so rounding sig figs, we always start from the left. You start counting at the first non-zero number. So I'm telling you to round to 4 sig figs. So I'm going to start from the left always. Start counting at the first non-zero number. So that's this guy. Count to the correct number of sig figs. So 1, 2, 3, 4. Okay, round that number. If that number is a 0 before the ones position, it's not, then turn into scientific notation, but that's not the case. So for every number after the rounded position, so we're talking about 5. So I know I have to do 1, 3, 5 point, and then what's going to happen to that 3? It's going to round to 4, but now what do I do with that 5? If it is before the decimal, turn it to 0. If it is after a decimal, you drop it off. So that would just drop away. So my final answer to 4 sig figs was 135.4. Remember, you're trying to change the, you're rounding the number, but you're not changing the value of the number. Okay. So the 2 sig figs. So always start from the left. Okay. Start counting at the first non-zero. So 1, and I have to go to 2. Round that number. So 1, and that goes to a 4. All right, so that's to step 4. Step 5, for every number after the rounded position, okay, so this 5 is before a decimal. What I need to do is turn it to a 0. If the numbers are after the decimal, you drop them off. So my rounded answer is 140. And just to check if this has 2 sig figs, the decimal is absent, so we're going to start from the Atlantic side, and you'd start counting at the first non-zero, which is 1, 2. So yes, that does have 2 sig figs. All right, let's do this one. It has 3 sig figs. So we start from the left, start counting at the first non-zero. So it's 1, 2, 3. We're going to round that number. So it's 1.51. This 6 is after a decimal, so we drop it off. Okay, so it's 1.51. With this, you need to always keep it. Even though you're not counting it when you're counting sig figs, it is a part of the number. You are timesing something by 10 to the 4th. So it's really important to keep that number because otherwise you're talking 1.51 versus 1.151 and then 0, 0, right? So it's a big number difference. We need to keep that. So you just carry that right down when you're rounding. Okay, let's try the next one. 2 sig figs. Start from the left, start counting at the first non-zero, so that would be this guy right there. You don't count these zeros because they are zeros. First non-zero from the left, so that's 1, 2. So it's 0.06. That's going to turn to a 6. What's going to happen to that 980? Because they are after the decimal, drop them off. Now we need to do this to 3 sig figs. So 1, 2, 3. So it's 5.8. That's going to look at the next one, which means that it's a 0. Okay, it's not going to go up. These 3, 5, 4s are after, so you cross them off, so you end up with 5.80. Number 6 is by far and away the trickiest, and we're going to really emphasize number 4, step number 4 on this. So we're going to start from the left. I need to do 2 sig figs. I need to start counting from my first non-zero, so 1, 2. So it's going to be 1, 0. The problem is that I want to count this number as significant. If I just put another 0, that makes this number 100, which means that it really only has 1 sig fig. Okay? If I do 100 and then I put a decimal, that has a decimal, so you'd start from the left side, 1, 2, 3. That has 3 sig figs. Neither is the right answer. So what happens is we're going to look at number 4. So if it says, if that number is a 0 before the ones position, which this is, then turn to scientific notation and then do the rounding. And this technique actually can be used with absolutely any number. When you turn the number into scientific notation first and then round, it will 100% always work. Okay, so here we go. We're going to put a decimal, 1, 2. So now it's 1.00 times 10 to the second. That is the exact same number as 100. Okay, now I'm ready to actually round this. Okay, so what it says is start from the left, so 1, 2. Okay, now this 0 that I'm going to need to count for significant figures is after a decimal, so now 4 doesn't really play into position anymore, right? I don't need to worry about it because it's after, that 0 is after the decimal. So now what you're going to do is you're going to drop this guy. So you end up with 1.0 times 10 to the second, which means that you have 2 sig figs, which is the right answer. So if you ever have an oh crap moment, all you want to do is turn into scientific notation and round your scientific notation properly. Okay, so then you first had to know how to count sig figs. Second, you have to know how to round sig figs. And third, you need to know how to round when you're actually doing some application work, which is multiplication and division. We're not going to get into adding and subtracting in this class, okay? So, or at least right now, we're not going to. So we've got multiplication and division. So first, what you're going to do is you have to find out the sig figs for all, that shouldn't be 3. You should find out the sig figs for all the numbers, and then you're going to round to the lowest number of sig figs. So for multiplication and division processes, what you do is you count however many each number has for sig figs, and then you're going to round to that many numbers. So in this question, how many sig figs would I need to round to? 4.501 has 1, 2, 3, 4 sig figs. 0.001 has, starting from the left, only 1 sig fig. So whatever my answer is, I would have to round to 1 sig fig. Okay, 10.005 has 1, 2, 3, 4, 5 sig figs. 0.458 has 1, 2, 3 sig figs. So you're going to choose, so I can either round to 5 or 3 sig figs because I am multiplying. So what am I going to choose? I'm going to choose the lowest number, which would be 3. So I'm going to round to 3 sig figs. So let's say we had this thing of 3 times 10 with a decimal. Okay, I'm going to make easy math. All right, so what I'm going to need to do is I'm going to need to count however many sig figs I have. So 3 has 1, 10 with the decimal has 2. So my answer is 30. I need to round to either 1 or 2 sig figs. So in this case, I would round to 1 because it is the lowest number of sig figs. So I'm going to start from the left. I'm going to start counting at the first non-zero. We get 3. That 0 after, that's the one I'm going to round, so it's going to stay at 3. Because this 0 is after or is before the decimal, you just keep it as a 0. Okay, you turn all numbers after that rounding to a 0. So my final answer rounded to 1 sig fig would be 30. All right, hopefully you have a basic understanding of sig figs and can go and practice.